So, velocity of a heavy meteorite is inversely proportional to the square root of s when it is s kilometers from the Earth's surface. Show that the meteorite's acceleration is inversely proportional to s squared. All right. So, velocity is inversely proportional to the square root of s. Now, if I remember what these words mean,
It's 1 over root x.
Yeah.
well, k over root s. There's some sort of constant of proportionality. So if they were to say, and they didn't say this, if they said velocity was proportional to s, we would write velocity as ks.
Oh, yeah.
If it was proportional to the square of s, we would say it's ks squared.
What does the K stand for?
It's called a constant of proportionality. It's some value that we'll be able to find later. Right? Okay, inversely proportional would be read as k over s. Or inversely proportional to the square root of s, k over root s. Show that the meteorite's acceleration, well, we're given a velocity equation and we want to find something that has to do with acceleration. How do we do that? Acceleration is the derivative with respect to
Position? Yeah, no, velocity.
Velocity.
No, time.
K.
it's with respect to
dd
time.
ddt of velocity.
There's no time here.
No, there isn't.
So would we be using the free falling to Earth?
Maybe with respect to K, which could be time.
No. K is a constant.
It's got to be t.
There's no T. Yeah.
Oh,
Distance from Earth, that's what it's
no. Here's what's missing.
Oh, times time. Okay.
Position is a function of time. Position is a function of time. All right. By the way, if you don't mind, I'm going to rewrite this in a way that may
Makes
make our
sense.
life a little bit easier.
The negative
t
one.
equals k
Okay.
All right.
s t.
So if I took the derivative of k times s of t to the negative 1/2, so it's going to be k times the derivative of this. And this is where the chain, this is chain rule, right?
Yeah.
That's the topic in this section.
Yeah.
It's
So I'm going to bring the exponent down, leave the inside the same.
I thought it was derivative of the outside. Inside
Yeah,
root is the same.
Right, the derivative, the outside function is the negative root function.
Oh, okay.
So I'm taking the derivative of the negative root term, which brings the exponent down, leave the inside the same, and then this gets bigger by, this gets
Negative one.
smaller by 1.
Over x.
So that becomes, goes from negative 1/2 to negative 3/2,
Then times s prime of t.
then times s prime of t. Indeed. That's a pretty big mess. I wonder if there's anything we can do to clean that up. Well, negative k over 2. And I'm going to write this. I'm going to write this part in the bottom to the 3/2 power.
I have a question.
Yes.
Never mind.
All right.
I was wondering about how the negative one happened. Okay. But I got it. It's cool. We are set.
All right. And now I got this s prime thing to deal with. If I only had a way of writing s prime, if I only had a way of saying, what is the first derivative of position?
Velocity.
Oh, I do have a way of writing s prime. This is s prime. It's the velocity.
Okay.
So k times
So k over negative k over 2.
to the negative 1/2 power. Now, can we clean that up a little bit further? Negative k squared over 2, which I really don't care about. What I care about is what happens to these s's. One of them is s to the negative 1/2. Wait, the negative 1/2 is on the wrong side of the fraction bar. What happens if I put it on the other side?
Then you get, to the, well, to the 1 power.
No, not, okay, Ethan's got it right, it's s squared. If I'm taking this 1/2, I'm saying it's on the wrong side of the fraction bar. When I put it into the denominator, I end up adding the exponents. Okay. Side, it's kind of like this.
Oh, then it's 4 over 2,
It's
yeah.
negative 1 over x squared, for example.
It's 1 over x cubed.
That's in 1 over x cubed, because when I bring this boy down, the negative changes into a positive, and I add the exponents. When I bring this red expression down, it goes into the denominator and becomes s of t quantity squared. And how would I describe this? Some constant of proportionality.
Why is k squared?
Well, because there was a k
Negative k.
here and here. But it doesn't matter. All I'm saying is there's some constant of proportionality out in front. And how would I describe this? Inversely proportional, because it's at the bottom, to s squared.
So wait, how come the k jumped from the right side to the left side? How did the k get there?
How did the k go from the left side?
Because when it's written in red up there, how did it suddenly get with
No,
the
because
negative k?
this k, the red k, is from here.
Well, why does
It's-
it, he's saying why does it move to the, why do you take it out of that fraction, move to the negative two?
Yeah.
Well, this whole thing is being multiplied together.
So it's really just all over one. It's all over one bar. So it's
Yes.
negative k
This
squared.
is
over
like
2s
one
to-
big large fraction bar, there's a multiplication sign right there.
And so is the bottom one that you have circled right.
Right.
Okay.
There's a,
Alright,
Okay.
I was a little confused. Okay.
but in general, it's some constant times 1 over s squared. Which shows what they wanted to do. It's inversely proportional to s squared. All right? Yeah, that was fun.
Is that the end of it?
That's it. I showed that it's some constant times 1 over s squared.
What is
Show
this?
that it's inversely proportional. There's my constant of proportionality.
Okay.
Inversely to s squared, 1 over s squared.
Alright, I guess it works.
I don't know, overall it's just
Well, again, I need you to know what those words, proportional, inversely proportional, what they mean. And if to show it to be inversely proportional, I have to show it to be something, well, what they were asking for is show that acceleration is some constant over s squared.
But that
I'm
constant
saying
is squared.
I'm saying that thing in its totality is a constant.
Okay.
It's some constant. And I don't care that it says k squared. I don't care if it says pi. It's a constant. To show it's inversely proportional, I have some constant on the top, and I've got s squared in the bottom. I meet this criteria with that answer.
Okay.
But what if it was negative k cubed over 2? Would that...
Is negative k cubed over 2 a constant?
Yes.
Then it's a constant. Some constant.
Okay.
Okay, don't get hung up on the fact that this is a k.
Well, it's
could-
not the fact that
this
it's
could-
k, it's the fact that
This
it's
could
squared.
be, a curling disc instead of a K. I really don't care what it is.
That
Curly
was really
stone.
well. That was really well drawn.
I was gonna, actually, I wanted to draw a watermelon, and I realized I can't draw a watermelon. So it's like, what is that gonna be? Oh, it's gonna be a curling stone.
That was really well drawn.
Hooray! Very hard! I love curling. All right.
They say